Hello everyone, this is Rahul Shrestha, and after a really long time I'm back again to present you the fifth part of the chapter Matter for class 8. So if you remember, in our previous class we read a lot of different things about atoms where I discussed about some of its properties. Now let me just recap these properties before I move ahead with the chapter, as it's been almost 2 weeks now that we last read about them. So till now we know that all matters are made up of atoms. And atoms are the fundamental building units or fundamental building blocks of all matter. There are in total 118 different types of atoms that we know about till this date. Then we read about the structure of the atoms and understood that atoms contain some even smaller subatomic particles inside them, which are the protons, neutrons, and electrons. Where the protons are the positively charged, electrons are the negatively charged, and neutrons are neutral or has no charge. Protons and neutrons forms the dense inner core of an atom known as the nucleus, whereas the electrons revolves around the nucleus in their own orbits or cells. Then we also read that different atoms of the same element are similar, whereas the atoms of different elements are different from each other. Now this property of the atom gives rise to a question. And the question is that why are the atoms of a single element similar? And how are they different from the atoms of the other element? And the answer behind this question is the structure of the atom, or rather the protons, neutrons, and electrons present inside an atom. See, the thing is that atoms of different elements have different number of protons, electrons, and neutrons inside them. And for this reason, the atom of one element is different from the atom of another element. Like for instance, an atom of oxygen contains 8 protons, 8 neutrons, and 8 electrons, whereas an atom of carbon has 6 protons, 6 neutrons, and 6 electrons. And this difference in the number of these subatomic particles make a carbon atom different from an oxygen atom. And this is true for all the other 116 elements as well. Every single element contains a different number of these subatomic particles, and this is why they are different from each other. And in the same manner, every single atom of the same element always has the same number of these subatomic particles, and that is why all these atoms are exactly similar to each other. Now there are two more special properties of an atom which are in a way directly responsible for all the different characteristics of an element. And the properties are the atomic number and the atomic mass. The atomic number here, which is also represented as capital letter Z, is basically the total number of protons present in the atom of an element. So if I say that suppose an element X has 5 protons in its atom, it means that the atomic number of this element X is 5. In the same manner, the atom of the element having a total of 10 protons in its nucleus will have the atomic number 10. Now as you already know, in an electrically neutral atom, the number of protons is same as the number of electrons. So we can also say that atomic number is equal to the number of electrons in an electrically neutral atom. Remember, the atomic number will only be equal to the number of electrons in an electrically neutral atom, which has the same number of protons and electrons. And if the atom is not neutral, then it means that the number of protons is not same as the number of electrons. And in reality, atomic number is the number of protons only. But only because we know that protons and electrons are same in a neutral atom, that is why sometimes we say that atomic number is the number of electrons, but only for a neutral atom. Now the next property of an atom is its mass, known as atomic mass or mass number, represented by capital letter A. This atomic mass is simply the mass of an atom. Now, as we already know that atoms are made up of subatomic particles, we just find the total mass of these subatomic particles and call it as the atomic mass. So in order to find this mass of an atom, we need to add the mass of all the protons to the mass of all the neutrons and the mass of all the electrons. Now if you remember from our last class, I said that mass of one proton and that of one neutron is 1 AMU, and the mass of one electron in comparison to the protons and neutron is really small, and for this reason we don't consider the mass of an electron while measuring the mass of an atom. So if we try to find the atomic mass of an atom, let's say of boron, which contains 5 protons, 6 neutrons and 5 electrons, we need to sum up the masses of all of these, but because the electron's mass is almost negligible, we won't be considering its mass, and instead we'll add just the mass of all the protons and the neutrons. So here the mass of 5 protons will be 5 AMU and the mass of 6 neutrons will be 6 AMU, and if we add this up, we'll get 11 AMU as the mass of one boron atom. Now the thing is that because it is understandable that the mass of an atom would be measured in the unit AMU itself, that is why we don't generally write this AMU with the atomic mass, as it is implied that the unit is AMU. So instead of signifying the atomic mass to be 11 AMU, here we'll simply write it as 11. Now as atomic number and atomic mass are two of the most important properties of an element, we have a very peculiar way of representing these two informations. So suppose if we have an element X having atomic mass A and the atomic number Z, this has to be represented in this manner. Here this X is the symbol of the element, this Z is the atomic number which has to be placed as a subscript below the symbol of the element, and in the same manner A is the atomic mass has to be placed as a superscript above the symbol of the element. So if I need to show these information of some element, say fluorine, I would write it somewhat like this. Here this F again is the symbol or the short form of the element, this 9 here is the atomic number and 19 is its atomic mass. Always remember that atomic mass is kept above and atomic number is kept below the symbol. Now we can also use these informations in order to find out the number of electrons, protons and neutrons inside the atom. Like in the case of fluorine, we know its atomic number to be 9 and atomic mass to be 19. Now as we know that in a neutral atom, atomic number is equal to the number of protons and it is also equal to the number of electrons. This means that the number of protons and the number of electrons is 9 in this particular atom. In the same manner, we know that atomic mass is the sum of protons and neutrons. Now if we make neutron as the subject, we will get number of neutron to be the atomic mass minus the number of protons, which will be 19 minus 9, which is 10. So the number of neutrons in one fluorine atom is 10 and the number of electrons and protons is 9. So simply by using the atomic number and mass number, we can easily find out the number of the subatomic particles in an atom of any particular element. Remember, these type of questions are a lot of times asked in your examination, so do try to practice these yourselves. And if you have any doubt or difficulty understanding these, I would request you to please rewatch this video and understand all these concepts clearly, as this chapter will form the most important base for all of you on understanding chemistry nicely for your life. So with this, I would like to end today's class. We'll meet again the next time. Till then, take care and be safe. Thank you.